All right, so it wouldn't be a 60 Minutes in Space without talking about Mars. Steve's not here, but I'll try and channel our Steve and talk about Mars. So I know last month Steve mentioned the Opportunity rover unfortunately has ended its mission. We did some math. It's been there 15 years, traveled 28 miles, and sent us close to 219,000 images, which is incredible. So it stopped communicating with engineers back here on Earth on June 10th, but NASA has released one more image from it, and that was released this month. It's this beautiful panorama that is actually 360 from Opportunity's final resting spot in Perseverance Valley. So you can see the colors here are pretty dramatic. That's because it is a false color image. They've been enhanced significantly to be able to point out some different features. So if we zoom in a little bit, we can see parts of the spacecraft. There's the low gain antenna, there's some of the solar panels, but we also get glimpses of Opportunity's history here. We have its entry point into Perseverance Valley. We see the crater rim of Endeavour Crater, the hill on Endeavour Crater's rim, and just a lot of geologic features as well. So this is truly our final goodbye from the Opportunity rover, but a little rover that could, 90 days, stretched to 15 years. And we can now start really looking forward to both current and future missions that are headed to Mars, including InSight. Yay! So InSight's on Sol, or Martian Day 118 out of its 705 Sol mission. And it's had a lot of success already. It spent the first 3 weeks really just trying to get a lay of the land. What's happening with the area where they're going to deploy the instruments? What does the surrounding look like? And they have since deployed their two major instruments. This is SEIS, its seismometer, which has now got its little cover on top of it to help protect it from wind. And then HP3, which is our heat and physical properties probe, has also been deployed. But the news this month really is around the HP3 there. So let's talk a little bit more about it. We sent a mole to Mars, guys. Yay! So for those of you that haven't read it, the Oatmeal produced a really amazing comic around the InSight landing event and what the science of the InSight lander is. It's really accurate and really fun. I love to imagine we've got a little mole with a jackhammer here. Not quite how it works, but it is pretty close. So here is HP3, or the mole, deployed on the surface. So things that we're looking at. We've got the grappling hook from the robotic arm here. We've got this little nodule that is what the grappling hook used to grab the instrument and actually set it down. And then one thing, catch me on if I say it wrong, is this is not a drill, but more of a hammer that is working to dig its way down onto the surface, into the surface of Mars, hopefully 16 feet. And so it works by having like a little spring up at the top that they push up, that coils up, and then they release that pressure, and it hammers down. So think more of a jackhammer than a drill. And this little drill was deployed and started working on February 28th, so just after last month's 60 Minutes in Space. And it got about 4,000 hammers in before it hit trouble. So what's happened is there's two obstructions that it's encountered. There was a first obstruction here that they think was likely gravel, that it did drill past, or hammer past. I told you, catch me if I say drill, right? A hammer past, but it actually tipped the mole just about 15 degrees. So there's actually images you can see it shifted it on the surface even. But it was able to continue down, and it kept drilling. But then they hit a second obstruction, and we don't know what this is. So March 3rd, they tried to turn the drill back on and drill past it, and they didn't have any success of getting any further in. So for now, we've stopped all hammering, and we're about probably a foot down. The estimates range from 7 to 20 inches. And they're trying to figure out what it is. Is it a small rock? Is it regolith that is just really compacted and is hard in that spot? We're not sure. But the good news is that we have an engineering model of this here on Earth in Germany, which is where the spacecraft was built. And they're doing testing to figure out how they can get past that. Is it safe enough to just keep hammering and see if it'll break it apart so we can test with rocks and compacted soil or regolith here on Earth? Or can we do some creative solutions? So they're looking at, could the robotic arm be strong enough to actually push on the top of it as it hammers down and force it past? Because maybe it's just not seated strongly enough on the surface. There's also talk of lifting it up very slightly and setting it back down. We don't know. The big and obvious solution would be to retract the drill or the hammer, but unfortunately we can't do that. It's not designed that way. Once it's deployed, it's deployed. So we couldn't drill into another spot. So hopefully they will find a way to get past that. Really, the goal is to get 10 to 16 feet deep, because the goal of this instrument is to measure temperature. So as it's going down, it's taking measurements of how much heat could these different spots in the regolith can hold. It's called thermal conductivity. But as it goes down, it'll deploy a little ribbon of sorts that will have temperature probes at various spots on the way down. So they'll measure temperature at different depths. Theoretically, we can extract that down to the depth of the core, and that's one piece of evidence that would tell us whether the core of Mars is solid, which is what we think it is, or if there is a molten core at all. So we'll see. Send your good thoughts its way. Hopefully here on Mars it'll work. We were just joking. We were doing some repairs in our Mars diorama for a seismic experiment, and we were drilling holes in Mars, wishing we could be there to help out InSight. But NASA hasn't sent people there yet, not willing to send us. But it has had some really good successes. So I want to talk about some of the successes so far. It's not just HP3 that's been working. SEIS is deployed, it's seismometer, it's functional. It hasn't detected any Mars quakes yet, but that's to be expected. We think about 10 to 12 events will happen per year, but we know it's working. We also know the temperature probes that are on the top of the spacecraft itself are working as well, because we've had a really unique series of events. There have been several solar eclipses on Mars of Phobos here. So this is a picture from 2013 from Curiosity, and you can see Phobos passing in front of the sun in what we would call an annular eclipse. Covers about 50%, 2/3 of that surface of the sun. And so those temperature probes were measuring the ambient temperature. And in case you ever want to know the temperature on Mars, it's on a website. You can check. It was a whopping 4 degrees today. Woohoo! But it actually detected a temperature drop from this eclipse. It was dropped 33 degrees Fahrenheit over 30 seconds, which is pretty cool. I really like solar eclipses, in case you can't tell. I have one tattooed on my wrist. So I was like, solar eclipse on Mars, yes. And we can actually see it in this video here. So keep a close eye, and you'll actually see the camera has picked up how it gets a little bit dimmer. Just boom, quick. There's one image. And there it is. It's an eclipse. Woo! Again, I'm really excited. Thanks for indulging my excitement. So Opportunity, we know, ended up dying because of a dust storm, and a lack of power to its solar panels. So we are keeping an eye out on Opportunity. So this is Sol 10, and you'll see it pass by pretty quickly. We've got a lot of dust there, and that's okay. Just want to throw out, InSight's totally fine. No risk of that. We expect, just like happened several times with Spirit and Opportunity, some friendly dust devil will come and sweep away all that dust. But we are seeing dust, but it still has got plenty of power. This was an image taken by the robotic arm. There's a little camera on its elbow, basically. And you can also see in this one, there's that temperature probe. But hey, you ever wondered what InSight really looks like? Here comes museum advertising time. We're really excited. We are the first museum in a nationwide tour of museums to get a full-scale model of the InSight lander. So it is 19 feet, 8 inches, solar panel to solar panel. It's living in Space Odyssey. We'll be here through July 28th before it continues on. So this is on loan from NASA. It's a model commissioned by JPL. Our fabulous volunteers also have a cart they can facilitate with pieces of material that is very similar to the spacecraft. that you can touch and feel as well. So come check that out next time you're here. It's hard to miss right as you enter the gallery.